So let's take a look at our first example here. We're going to have a series of functions here that we want to find the derivative of, and we're going to be using the chain rule in each of these. So our first function is f at x equals the square root of x squared plus 5x. And first thing we want to do is think about what two functions have been composed together to create this complicated function. This becomes a little more clear, I think, if we rewrite our function as x squared plus 5x to the exponent 1/2. Just take that square root and turn it into an exponent. Then we can think of this as, if we think of this again as some outer function g and some inner function u, the inner function u is x squared plus 5x, and our outer function g at u is something to the power of 1/2. So u to the 1/2. So our derivative here, f primed at x, is going to be g primed at u times u primed. So what is the derivative of u? U primed is going to be, Van, what is the derivative here? 2x plus 5. Awesome. What is g primed at u here, our derivative? Malcolm, what are we going to have here? 1/2 u, and what's our exponent going to be? To the negative 1/2. So let's put this all together. We need g primed at u, which is 1/2 u to the negative 1/2, times u primed, which is 2x plus 5. Now let's take what we know as u and sub it in here. 1/2, instead of u, we're going to have x squared plus 5x to the negative 1/2 times 2x plus 5. Now, if we wanted to sort of neaten this up a little bit, we can recognize that if we've got x squared plus 5x to the negative 1/2, that negative exponent can kind of move that term down into the denominator. So we can have an x squared plus 5 all to the 1/2. This 2x plus 5 is going to stay up in the numerator. The 1/2 out front is a 1 over 2, so we could put the 1 up in the numerator and the 2 down in the denominator. So we don't really write the 1, we just stick the 2 down there. So it's 1 over 2. And there would be our final derivative expression. 2x plus 5 over 2 times x squared plus 5x all to the 1/2. And of course we could, if we really wanted to, change that exponent 1/2 into a square root. 2x plus x squared plus 5x. Okay. All right, let's take a look at another example here. It's pretty similar. Okay. Y equals 1 over square root of x squared plus 4. Now, we can do these chain rule questions by writing out explicitly what that outer function g is, what that inner function u is, and then writing out explicitly what the derivatives of each of them are. Okay? And that's a good place to start. But you want to get good at this and be able to just go straight from the function right to the derivative in sort of one line. Okay? So let's try that in this example here. So we've got y equals 1 over square root of x squared plus 4. First step, we're going to rewrite it. How are we going to rewrite it? Just to make it a little easier to work with. Right. Absolutely. X squared plus 4 to the negative 1 over 2. Changing the square root into 1/2, bringing it up from the denominator, making it negative. Then we're going to try to jump right to our derivative. Okay? So in our minds, we're going to recognize, okay, our inner function is the x squared plus 4. Our outer function, g to the u, is something to the negative 1/2. And we know that when we're doing our derivative, we're going to want g primed at u times u primed. Okay? So, oh, I got to move this down a little bit here. So our derivative is going to be, let's see, we can just sort of ignore what we have in the middle right now and just think of this as something in brackets to the exponent negative 1/2. If we're doing the derivative of something to the negative 1/2, we bring down the negative 1/2, we keep whatever that base is exactly the same, and then we subtract 1 from the exponent. So let's see, negative 1/2 minus 1 is going to give us negative 3/2. Okay? So this base stays the same. So we still want that stuff in the middle to be exactly the same. It's still x squared plus 4. And then we want to multiply by, well, the derivative of that thing that is inside the brackets there. So what is the derivative of x squared plus 4? It's going to be 2x, and then the 4 is just going to go away. Okay? So one line, well, 2 lines, I guess. We rewrote our function, and then we went right from our rewritten function straight down to our derivative here. And now all we have to do is simplify. So we've got a 1/2 and a 2 that are going to cancel each other out. So we're going to have a negative x up in our numerator, and then down in our denominator we are going to have a square root of x squared plus 4 cubed. Okay. The 3 up in the numerator means we are cubing our expression, and the 2 down in the denominator of our exponent means we've got a square root. Okay. Make sense? All right. Let's try one more here, which is a little bit weirder looking. Okay. So g at x is 1 over 2 over x squared minus 3 over x all squared. So same sort of steps as before. Let's first rewrite this to make it look more like the examples that we've done in the past. How are we going to rewrite this? What would you do, Jen? Well, what would you do with that exponent 2 first? I wouldn't expand it, no. Green? Yeah. So we can do this in 2 steps here. We can take that exponent from the denominator, move it up so it's in that term that's down in the denominator with the exponent on it, make the exponent negative so we can move that term out of the numerator. Okay? And then we can do the same thing for these individual terms that are inside. Okay? We've got 2 over x squared, we've got 3 over x. We can take each of those, make the exponent negative, okay? So it becomes 2x to the negative 2 minus 3x to the negative 1, and this whole thing is still to the exponent negative 2. Now we can jump straight to our derivative. We've got this set up so we've got this inner function 2x to the negative 2 minus 3x to the negative 1. All of that is, and our outer function is this whole thing to the exponent negative 2. So we're going to do the derivative of that outer function, basically bring down the negative 2, subtract 1 from our exponent to get negative 3, keep everything inside that bracket exactly the same. 2x to the negative 2 minus 3x to the negative 1. Then we're going to multiply by the derivative of what is inside those brackets, or that base to our for our power law here. So the derivative of 2x to the negative 2 is going to be, well, we bring down the negative 2 to get negative 4x to the negative 3, subtracting 1 from our exponent. And the derivative of 3x to the negative 1, we're going to bring down the negative 1 to get positive 3x to the negative 2, subtracting 1 from our exponent. And there's our derivative. Okay? Derivative of the outer function evaluated at the inner function times the derivative of the inner function. And that's the chain rule.